let's take a look at this. If we, again, treat each of the individual terms as a fraction, we can see our LCD, we need our 1, an x, a second x, so x squared x, 1. So the LCD here is going to be x squared. Because there's only that one unique LCD factor, it's a very efficient way to solve this using the LCD method. So if we take the LCD x squared, multiply by that over itself, and then just focus on the numerator to start with. When we distribute this through, it gives us an x squared minus 5x minus 24. In the denominator, when we distribute this through, it gives us a 15 plus 8x plus x squared. And so it's just a matter of factoring each of these. So in our numerator, the two factors of negative 24, whose sum is minus 5, is negative 8 and positive 3. And in the denominator, here again, if we just reorganize these, reorder them in standard form, the two factors whose of 15, whose sum is positive 8, are 8 plus 5, and x plus 5 and x plus 3. Okay, and so the last thing we can do here is cancel our common factors, and this leaves us with our solution x minus 8 in the numerator, x plus 5 in the denominator. Now, because we used LCD method, again, when we look at our domain restrictions, we look for any factors canceled in the denominators, which we see here, x can't be a negative 3, not apparent in the simplified form, so we do need to include that. And then when we look back into the original form, we see in each of these fractions here that the value of x that would give you division by 0 in each of these four fractions is 0. So x can't be a 0 as well. And so this would be your simplified form for that answer. Yeah, so the question is, if we set it up where we treat the numerator as a single fraction, its LCD will be x squared. So you would get x squared minus 5x minus 24 there. And in the denominator, the LCD would be x squared as well. And here you'd get 15 plus 8x plus x squared. And what's going to happen is when you invert and multiply, the x squareds cancel, but everything else will look exactly the same as what we did here. Again, remember the advantage to that this method up here, treating each one as a complex fraction, is that you'll be able to see that all the domain restrictions more easily versus this LCD method. You have to go back in and look for the additional domain restrictions.